This is problem number 1 on the worksheet. You could apply substitution here, or just expand the 1 plus 2x the whole squared and apply power rule. Okay? So either way, if you want to expand, this is going to become 1 plus 4x plus 4x squared times 2. Probably you could pull the 2 outside, dx. And then integrating term by term, this will become x plus 4 times x squared by 2 plus 4 times x cubed by 3. And distributing the 2, you will have 2x plus this would cancel 4x squared plus 8 by 3 x cubed plus c. You could have done this, or you could have done the same problem using substitution. If you have 1 plus 2x the whole squared times 2 dx, first choice for substitution is the inner function. So we have an inner function. So let's put u equal to 1 plus 2x. So du is 2 dx. So rewriting the integral, we have 1 plus 2x squared will become u squared. 2 dx is becoming du. So we have u cubed by 3, which will become 1 plus 2x the whole cubed over 3 plus c. This will be the final answer. Of course, if you expand it, you will get this answer. Let's do the second problem. Second problem is 1 over 2x plus e power x dx. This is a direct formula. We're going to do term by term. 1 by 2x dx plus integral e power x dx. So pulling the 1 by 2 outside, this is integral 1 by x dx. Of course, e power x dx. Both have formula. So we have half ln absolute value of x plus e is itself plus c. Okay, I'll move on to the third problem, which is solve the differential equation dy by dx equal to 10x squared over square root of 1 plus x cubed. So rewriting this as an integral problem, this will give y equal to integral 10x squared over square root of 1 plus x cubed dx. So this is finding the function whose derivative is 10x squared by square root 1 plus x cubed. So rewriting as a reverse problem, as an integral problem. So we need to do integration. Again, inner function is the choice of u. So we have this inner function, we're going to put this as u. U equal to 1 plus x cubed, du equal to 3x squared dx. Right. So we're ready to rewrite this integration. Integral 10, if you're going to have 10x squared as it is, then replace only the denominator. This is going to become square root u, and then if I copied the 10x squared, then we have only dx left. So we're going to replace dx. In that case, I'm going to get dx alone here, or you could have got x squared dx and push the 3 along that side. I think we will do that. Okay, so I will keep the 10 and combine the x squared and the dx together. So x squared dx will become 1 by 3 du. So x squared dx is 1 by 3 du. Pulling the constant outside, it will become 1 by square root of u du. So this is 10 by 3 integral u power minus half du. Of course, this will go on to 10 by 3 power rule, u to the half over half. So this will become 10 by 3, 2 by 1, u to the half. So final answer is written in x. So we have 20 by 3. U is going to be 1 plus x cubed power half plus c. Okay. Let me move on to the fourth problem. Fourth problem is easy. I'm not going to do that. Let's move on to the fifth problem. Integral cosecant squared x by cot cubed x dx. So here again choice of u is either inner function or denominator. We're going to use inner function. So there is an inner function, cotangent inner function, u equal to cotangent x, du equal to cosecant squared negative cosecant squared x dx. So du we are ready to rewrite. Denominator is u cubed, numerator is negative du. So this will become, pull the negative sign outside, 1 by u power 3 du, negative u power minus 3 du. Applying power rule, we will get negative u power minus 3 plus 1 by minus 2. This will become 1/2 u power negative 2, making it positive exponent u power 2. Final answer in x, so 1 by 2 times cot squared x plus c. I will do problem number 6, which is going to be e to the 2x plus 2e to the x plus 1 over e to the x dx. The main trick here is to view the e to the 2x as e to the x whole squared. You have to see this, only then we could solve. Here we're going to use denominator as u. So we're going to use the denominator, choice of u, e to the x, du equal to e to the x dx. Now we are ready to rewrite. Denominator is u and e to the 2x. E to the 2x is e to the x the whole squared. This is going to be u squared. So first term becomes u squared plus 2u plus 1, and then dx has to be replaced. So we have dx is going to be, we're going to get dx from here alone. Dx is going to be 1 by e power x du. So if you're going to copy it exactly like that, 1 by e power x du, then you have an x and that has to be replaced by u. So in the next step, or you could replace it here itself. So in the next step you have u squared plus 2u plus 1. This e power x has to go. It has to become an expression in u. We're going to put u, 1 by u du. Okay. So this will become integral u squared plus 2u plus 1 over u squared du. Split the fraction. Integral 1 plus 2 by u plus 1 over u squared du. Term by term integration. So first term will become, maybe I will rewrite this, integral 1 du. So I will rewrite it as 3 integrals. So 2 by u, we're going to pull the 2 outside, and 1 by u du. Third integral is integral u to the negative 2 du. Okay. So this is going to give integral 1 is u plus 2. Integral 1 over u is ln absolute value of u. And the third integral is u power minus 2. Applying power rule, you will have u power minus 1 by 1. So making negative exponent positive. So this will become negative 1 over u. So one more step, go back to x. X is, u is e power x. So e power x plus 2 ln absolute e power x minus 1 over e power x plus c. Okay, this will simplify further to ln ex will become just x minus 1 over ex plus c. Okay. Actually, we've used the substitution technique here. This problem can be done even without substitution by simplifying the starting integral. I will show you how. So next math, same problem, but not using substitution. You can rewrite the expression and it is going to get ready for formula. split the fraction to start with. So we're going to split the fraction. So e power 2x by e power x plus 2 e power x by e power x plus 1 over e power x dx. So this will simplify to e power x plus 2 plus e power minus x dx. So this was the term by term integration. This is going to give e power x plus 2x minus e power minus x plus c. So which is going to be e power x plus 2x minus 1 over e power x plus c, which is the same answer we got here. Okay. So this is, if you can simplify the expression, you don't need substitution rule here. Okay. Let's do problem number 9. We have x squared plus 2x plus 3 over x cubed plus 3x squared plus 9x dx. So choice of u is going to be the denominator. There is no inner function here, so let's choose u to be the denominator, which is x cubed plus 3x squared plus 9x. So du equal to 3x squared plus 6x plus 9 dx. So we want to factor a 3 outside. So basically we're going to look at this, look at the numerator. So somehow we want to match this numerator with this expression. So I'm going to pull the 3 outside. So x squared plus 2x plus 3 dx. So this part is the numerator there. So we're going to move the 3. So 1 by 3 du equal to x squared plus 2x plus 3 dx. Yeah, we're ready to rewrite. Numerator is 1 by 3 du. Denominator is just u. Okay, so pull the 1 by 3 outside. So integral 1 by u du. This will become 1 by 3 ln absolute value of u. Going back to x, ln absolute value x cubed plus 3x squared plus 9x plus c. Okay, let's do this problem. Integral 1 to 3 e to the 3 by x over x squared dx. Okay. Note that we have limits. We're going to apply limits. Okay. So we want to remember this. Alright, so this again a u sub. Choice of u is the inner function. So we have a e function and the inner function is 3 by x. So u is going to be 3 over x. That is the inner function. E is the outer function. So du, let's rewrite this as 3 times x power minus 1, so that we could do derivative. Du equal to 3 times negative 1x to the negative 1 minus 1. So this is going to be times dx. So du equal to negative 3 x to the negative 2 dx. Make a negative exponent positive, so 3 over x squared dx. Right, so I'm going to rewrite this as e to the 3 by x 1 by x squared dx. So the x squared in the denominator, so I'm just writing it as 2 fraction just to associate this with this part. Right, so we have we only want 1 by x squared dx. So 1 by x squared, we're going to push the negative 3 to this side. Negative 1 by 3 du is 1 by x squared dx. So this will become e to the u. 1 by x squared dx is negative 1 by 3 du. So pulling the constant outside, e power u du. E function is itself e power u. Go back to x, e to the 3 by x plus c.